Dear viewers, in this video we will deal how to balance an equation by the oxidation number method in acidic medium. So we are taking an example here of this equation. Now first step in doing this balancing is to write the oxidation number of each atom involved in the reaction. So let's see first how to write the oxidation number of each atom in the reaction. Here we have to find the first oxidation number of chromium. So by using the method that I have told you before in the video, that consider it as X and find the oxidation number of chromium. So let's find it out by taking it as X. Here I am using a rough work, Cr2O7 to negative. Now here chromium oxidation number will take it as X, so it will be 2X plus oxidation number of oxygen is -2 and 7 2s are 14, so -14 is equal to -2 because the charge on the ion is -2. Now let's solve it. 2x minus 14 is equal to -2 and 2x is equal to 14 minus 2x is equal to 12 and x is equal to plus 6. So here the oxidation number of chromium comes out to be plus 6. So here the oxidation number of chromium we will write as plus 6. Oxygen oxidation number here is -2. Iron, because it is in +2 oxidation state, so here the oxidation state will obviously be +2 of iron, that is in ferrous state. Hydrogen is showing the oxidation state of +1. Chromium here is showing +3 oxidation state, iron +3 oxidation state, and in water hydrogen is +1 and oxygen is showing -2 oxygen state. Now in next step, this is step 1, and in step 2 we will see the change in oxidation number. Chromium is showing the change in oxidation state from +6 to +3, and iron is showing the change in oxidation state from +2 to +3. Okay, so these are the changes in oxidation state. This is reduction, and chromium is undergoing reduction, and iron is going oxidation because there is an increase in positive charge. So this is oxidation and this is reduction reaction. Now next step is we have to balance the chromium and iron atoms in this equation. So in step 3, firstly we will equalize the two atoms which are undergoing oxidation and reduction. So we'll copy the equation again, that is Cr2O7 plus Fe2 positive plus H positive will give you Cr3 positive plus Fe3 positive plus water. Now here you can see the chromium is 2 in number, so here I will again put 2 to equalize the chromium atom, and iron is 1 on both the sides, so I need not balance it. Now here you can see in step 4 we'll determine how many electrons are needed to gain and lose by the respective atoms. In chromium it requires 3 electrons to be gained to convert its oxidation number from +6 to +3, and iron requires -1 electron to convert it from +2 to +3 oxidation state per atom. Chromium requires 3 electrons to be lost per atom, and iron requires 1 electron to be lost per atom. Now because there are 2 chromium atoms, so total electron lost will be 6 here, and there is only 1 iron atom, so here it will be +1 electron. So the coefficient for multiplication for chromium will be 1 and for iron will be 6. So now in step 5 we'll multiply with these coefficients the entire equation. Cr2O7 plus Fe2 positive plus H positive will give you 2Cr3 positive plus Fe3 positive plus water. Now we'll multiply iron by 6 and chromium by 1. So chromium we need not multiply because it is 1, and for iron we multiply it with 6. So here we'll put 6 and here also we'll put it 6. Now this is step 5 has been completed. Now you can see the atoms other than hydrogen and oxygen are already balanced in this. Chromium is balanced and iron is already balanced. Now next is step 6. In this we have to, because it is carried out in acidic medium, this equation is being carried out in acidic medium. So for balancing the oxygen atom, again we'll copy the equation. 6 Fe2 positive plus H positive will give you 2 Cr3 positive plus 6 ferric ions plus water. Now here you can see, to balance the oxygen atoms we have to add the corresponding number of water molecules on the right hand side. Now here you can see 7 oxygen atoms are there, and here only 1 oxygen atom is there. So I need 6 more water molecules to be added here. So I have added 6 water molecules to be on the right hand side to utilize the oxygen atom. So it will become 7 water. So here we will write, instead of this we will write 7 water molecules instead of 6 water and water. And now to equalize the hydrogen atom, here you can see how many, 7 to the 14 hydrogen atoms are there, and here only 1 hydrogen ion is there. So I will add plus 13 more hydrogen ions on the left hand side to equalize the hydrogen atoms. Now the equation comes out to be in step 7 as Cr2O7 2 negative plus 6 ferrous ions plus 14 H positive. I have added the 13 and 1 H positive ion to get 14 H positive ion, 2 chromium ions plus 6 ferric ions, and I have added 1 and 6 water molecules to get total 7 water molecules. So this is the complete balanced equation in the acidic medium. So these are the steps that we have to follow in balancing an acidic equation. You can just go through it once again. Firstly, you have to write the equation and put the oxidation number of each element correctly on the top of each element in the equation. Then we have to identify the atoms which are undergoing a change in oxidation number. So I have identified here 2 atoms, chromium and iron. One is undergoing reduction, undergoing oxidation. Then we have to equalize the 2 atoms on both the sides by multiplying it with suitable numbers. Here I have equalized chromium atom because iron is already balanced. Then you have to determine how many electrons are lost and gained to carry out the change in oxidation number per atom, and then if there are more than 1 atom, we'll multiply it accordingly to get the total number of electrons to be added or lost, and then we will determine the coefficients for multiplying it with that corresponding atoms, and then the coefficients will be multiplied in the entire equation. Like here coefficient for iron was 6 and for chromium it was 1, and I have multiplied it in the entire equation. And then if it is carried out in acidic medium, we have to balance oxygen atom by adding corresponding number of water molecules, correct number of water molecules on the right hand side, and similarly hydrogen atoms will be balanced by adding the suitable number of hydrogen ions on the left hand side, and you will get the complete balanced equation as it is. In the next video we will deal how to balance equation in an alkaline medium.